Welcome to ClickMyProject.com.
Now we discuss about the product for a 0.45 volt 14.6 nanowatts CMOS subthreshold voltage reference with no resistors and no BJTs. Next, we see the abstract for the product. With the emergence and development of the Internet of Things and human body area networks, a serious challenge is put forward a low power IC as an essential module in analog and digital circuit systems such as charge IC applications. Low power sub-band gap voltage reference, particularly sub-threshold CMOS voltage reference, have been attracting increasing attention. Voltage reference reduce the power consumption and the die area by using MOSFETs working in a deep triode region, taking their places of the resistors, and the active load can provide better temperature compensations. However, they only work in a supply voltage ranging from 1.4 to 3 volt and from the 1.6 to 3.6 volt respectively. Non-sub not sub 1 volt, a sub-threshold CMOS voltage reference using a MOSFET of a high threshold voltage can be achieve an ultra-low supply voltage 0.45 or less, but larger temperature coefficient limits its applications. Recently, the resistor-less and low-power reference in has used one bipolar transistor, limiting the minimum supply voltage to 0.7 volt. In addition, the structure of circuit is complex, increasing the area and power consumption. However, unlike the accurate bandgap reference circuits such as the which are less sensitive no process corners problem of MOSFET in subthreshold in the threshold voltage variation that may result in the significant result variations up to the 15% of worst case considered as to overcome a formential problem, a new subthreshold voltage reference circuit reducing the process of corner variation is proposed, which uses the different body bias voltage through the current trimming to dynamically control the voltage threshold of the MOSFET. By introducing the novel body compensation technique, the deviation of voltage reference because the process variation reduced in 2.6 whereas it is a 3.8 without trimming. The brief is organized as follows in this section. We represent a low voltage, low power CMOS subthreshold voltage reference with no resistors and no bipolar junction transistors in a wide temperature range. The temperature stability is improved by second order compensation by employing the bulk driven technique and the MOS transistor working in the subthreshold region. The supply voltage and the power dissipation are reduced. Moreover, the trimming circuit is adapted to compensate for the process related reference voltage variation. The proposed voltage reference has been fabricated in 0.18 micrometer and 1.8 volt CMOS process. The measurement results show that the minimum power supply voltage is 0.45 volt. The power consumption is 14.6 nanowatts. Next, we see the flow diagram for the product. First, we given the input voltage signal for applied to our required CMOS designs process. Our overall process was developed based on our CMOS designs. This design consists of the PMOS and NMOS transistor to be combined and processed to some circuit based reference, and we developed the reference voltage circuit designs based on our body bias circuit and the bulk driven current generator circuit and the startup circuit design and the output voltage process. These circuits are consisted and processed by the overall reference voltage circuit designs. This is the final output to be generated the sub-threshold CMOS required output voltage for threshold level. Based on our threshold level is 0.45 based process, and to set the threshold level to maintain the voltage level for 0.45 volt, and the current trimming circuit design to be in the next step for the overall circuit based designs. This current trimming designs is based on our apply the data input for overall circuit and to process all the things and to vary the subthreshold voltage level based on our applied inputs. These inputs are consist of the 5 bits to be presented in our overall architecture. This circuit to be processed by our required output voltage and to generate the final reference voltage for our required current trimming circuit. The trim the voltage level base using to the startup circuit and the body bias circuit designs. Then the voltage reference circuit based on our current trimming circuit designs and to reference the voltage for using the bulk driven current generator and the current trimming methodologies. The two methods to be processed by our current trimming circuit, and finally we simulate and synthesize the overall circuit design and to represent the graphical results for our overall architecture. Our overall process was developed in the Tanner software. This is the final flow for our Subthreshold product. Finally, we see the output for the product. This is the design for our overall bulk current driven generator based subthreshold design. This design to apply the 0.45 volt for input VDD voltage and to apply and control all the signal and apply the reference voltage for 0.320 volt and the current 11 milliamps to be presented in our overall current bulk driven generator based subthreshold voltage CMOS circuit design. This design was all developed based on our CMOS oriented, PMOS and NMOS transistor oriented designs process and to apply all the voltage and to generate the final output for our required subthreshold based CMOS designs. This is the final graph for our subthreshold CMOS design based process. The voltage reference is only placed on our 0.45 millivolts or 45 millivolts or 0.45 watts volt to be applied for our reference voltage level. This is our the input for reference voltage input for 320 millivolt, and this is our the bulk driven current generator output. This is our the final structure for our overall bulk driven current generator based subthreshold voltage. Next we see the current trimming based subthreshold voltage design doing the cell 3 schematic diagram. This is our the final schematic diagram for current driven bulk generator. This generator based on our not a single input voltage reference, it apply the 5 input voltage reference. This data to be changed and the voltage level to be changed for any input VDD voltage. This is our the final design for our overall architecture, and see the output for the current trimming based voltage reference circuit. This is the final graph for our current trimming based voltage reference circuit. This is our the 320 milliwatts and the voltage reference to be placed in the 5.15 volt for our overall voltage reference output. This is our the current trimming output for final graph.